This section is on inverse trig functions integration-wise. So we're going to have rational functions that integrate into an inverse trig or an arc trig equation. Now, when we derived our inverse trig functions, the derivative was always u prime over square root of 1 minus u squared, or u squared minus 1, or 1 plus u squared. But there was always a 1 there. Then when you derived and you simplified some of those problems, it ended up changing a lot of times into another number other than 1. So, taking that into account, the indefinite integrals look a little bit different than the derivatives. So we're going to take arc sine. The indefinite integral of du over square root of a squared minus u squared, all right, where a is a number and u is a variable term. And the antiderivative of that ends up being arc sine of u over a plus c. The arc sine of the variable term over the number term plus c. And then similar things happen with arc tan and arc secant. You need to remember that a is the number term and u is the variable term. So if you have a squared minus u squared under a radical, a number minus a variable term under a radical, that's going to be when you antiderive into an arc sine. If it's a squared plus u squared under the radical, with no radical, that's going to antiderive into an arc tan. And if it's a variable term times a radical with the variable term squared minus the number term, that's when it's arc sec. So the number comes first with the sine under the radical, the number comes second with sec under the radical, or arc sec and arc sine. So we will integrate one of each of these. Remember, the derivative of sine is the derivative of arc sine is the exact same thing as the derivative of arc cosine, except for the negative sign. Same with cotan and tangent, and sec and cosec. That's why we only gave you 3 integrals here, because with the negative sign, you can just antiderive and make it a negative indefinite integral instead of memorizing 6. You only have to worry about the 3. So, we start with this indefinite integral. Dx over square root of 25 minus x squared. So I have a dx on the top, I have a radical on the bottom with a number minus a variable term. So this is going to be an arc sine integration. So I have a squared is 25. That means a is going to be 5. U squared is x squared. That means u is going to be x. So this will end up being an arc sine of x over 5 plus c. Now we have one where we have no radical on the bottom. So if you have a rational function with a number or just a dx on the top, no variable terms, and something looks like this on the bottom, a number plus a variable term, okay? A lot of times that's going to end up being an arctan integration formula. So the integral of dx over 5 plus 16x squared. At this point, it probably is going to help to set u equal to the u term or the variable term, and a equal to the square root of the number term. So in this case, u is going to be 4x, because the square root of 16x squared is 4x. A is going to be the square root of 5. Once you have that, then you want to find du for dx, and dx itself is 1/4 du. Now you can come back and substitute. You're going to have a squared plus u squared. So you take care of that, and you need your dx, which is 1/4 du. So you have 1/4 a squared plus u squared on the bottom, du on the top. You've substituted for everything in the integral. Now you can antiderive. This indefinite integral is the exact same thing as your arctan. So you get 1/4 times 1 over a, which is radical 5, so 1 over radical 5, arctan of u over a. So arctan of 4x over radical 5 plus c. Then you want to clean it up out front and make this one fraction. 1 over 4 squared roots of 5, arctan of 4x over radical 5 plus c. Now we'll do one where you have an arc sec. dx over x times square root of 9x squared minus 49. So again, set your u and your a up right away. You look at this, you say, okay, I think it's inverse trig, so you need a u and an a. U is going to be 3x, because the square root of 9x squared is 3x. A is going to be 7. So you get a is 7, u is 3x, then derive. Du equals 3dx. And now you start substituting. We need, under the radical, u squared minus a squared. That fits perfect. So we've canceled out under the radical, or we've substituted for what's under the radical. U squared minus a squared square root. I need a dx. 1/3 du equals dx. So I put du over 3. dx is taken care of. Du, put the 3 on the bottom. Now you also need to substitute in for this x. U equals 3x. So u over 3 is going to equal x. So you can put u over 3 in for that x. Now you've completely substituted this entire indefinite integral in terms of u's. Now you can simplify a little bit. 3 times u over 3 is just going to be u. So you get du over u times square root of u squared minus a squared, which is the exact indefinite integral that leads to an arc-seek. So you get 1 over a, 1 over 7, arc-seek of absolute value of u, which is 3x, over a, which is 7, plus c. Now we'll see another one here where we're going to have e to the x inside. You get the indefinite integral of dx over square root of e to the 2x minus 1. Well, you look at it and you might think arc sine right away, because it's dx over the square root of something squared minus something squared. But arc sine is number squared minus variable term squared. This is backwards, and you can't switch that order around. So this is not going to be an arc sine. What you're going to do is you're going to use your u substitution, and you're going to manipulate this a little bit and see where you go. We're going to let u equal the square root of e to the 2x, which is e to the x. A is just going to equal 1. Square root of 1 is 1. So the derivative of u is going to be e to the x dx. So we go to substitute. We have square root of u squared minus a squared on the bottom. Taking care of the denominator. We have a dx on the top. I got to substitute a dx in. Well, du equals e to the x dx. So du over e to the x equals dx. But I have a u and an x over here. I need everything in terms of u to be able to antiderive, to be able to substitute and integrate. E to the x is the same as u, so this is du over u. So I substitute du over u in for dx. So du over u is dx. Done. Now I've totally converted this from x's to u's. Now I simplify, leave the du on the top, throw the u on the bottom. Now I have an arc-seek integration formula here. 1 over a out front. Well, a is 1, so we just have an arc-seek. Absolute value of u over 1 plus c. Arc-seek of e to the x plus c. So the trick here was letting u and a equal their numbers, going through, rewriting in terms of u, and realizing right away that this was not a number minus a variable, so I couldn't use arc sine. Now, just like with all the other rules, all the old rules still apply. So it's not always going to be just an inverse trig integral. So you get the integral of 3x plus 7 over square root of 10 minus x squared. So that's not an inverse trig right away. But we can split this up. The top is not the derivative of the bottom, so u substitution won't work here. So if you split this up into two quotients, two fractions, you get 3x over this radical plus 7 over this radical. So the integral of 3x over this with respect to x plus the integral of 7 over this with respect to x. And now you now you antiderive or integrate each of these separately. Over here, the top is close to the derivative of underneath the radical, so you just use u substitution for the first part of the integral. Over here, this is going to be an inverse trig antiderivative, in this case a number over square root of number squared minus variable term squared. So this would be an arc sine integration. I'm not going to go through and show you this one, but you can see where you would split it up and then use each of those rules that you now know. Last one. A lot of times you'll see an indefinite integral where you'll have a number on the top and a quadratic on the bottom. And they'll ask you to find the indefinite integral. They'll ask you to anti-derive. Well, in order to do that, you're going to have to go back to your Algebra 1, your Algebra 2, pre-calc. You've done this for several years now, completing the square. We're going to need to rewrite the quadratic as a perfect square. So, we get the integral of dx over x squared plus 10x plus 39. So we get a number on the top, 1 dx, over a quadratic on the bottom. I need to rewrite this quadratic as a perfect square. So we're going to just do that on this slide, and then go back, substitute it in, and work our way through. X squared plus 10x plus 39. In order to complete the square, x squared plus 10x plus something is going to be a perfect square. I throw the plus 39 on the outside. I want to make this a perfect square. X squared plus 10x plus something. Well, x squared plus 10x, perfect square-wise, that would be x plus 5 squared. Would give me x squared plus 10x, and I would have a plus 25 here. X squared plus 10x plus 25, so I add 25 here, but I still want the overall value to be the same, so I subtract 25 on the outside. X squared plus 10x plus 25 plus 39 minus 25 would simplify. These would cancel, and you'd still be left with what you started. So these two are equivalent, just different forms. Now you want to write this as a perfect square. This can be written as x plus 5 squared. 39 minus 25 is 14. So now you have something squared plus a number. So you completed the square with this, rewrote it in a different form so that you had two terms, and that will help us integrate. So x plus 5 squared plus 14 is equivalent to x squared plus 10x plus 39. So I rewrite this indefinite integral as dx over x plus 5 squared plus 14. Now it fits the arctan integration formula perfectly. A number, or dx, over variable squared plus number squared. Actually, since there's no square root, it doesn't matter the order of the denominator. So u is going to be the variable term that's squared, so u is going to equal x plus 5. A is going to be the square root of the number, so a is going to be square root of 14. So now this fits. Du over u squared plus a squared. Anti-derive arctan is 1 over a, so 1 over square root of 14. Arctan of u over a. Arctan of x plus 5 over 14 plus c. And that's it. That's the 3 inverse trig rules for integration. Remember, it's rational functions where the numerator is a number or just dx or dt or whatever the variable of integration is, and the denominator is either under a radical or squared and a number term on the bottom.